Hello everyone, welcome to another Android beginner tutorial. In this tutorial we are going to talk about layouts. I'm using the same project from the previous tutorial. To align the elements or the UI of the screen that's shown, we use something called as layouts. And here by default the layout that's used is called the constraint layout, but there are different types of layouts that we could use. These are the layouts that are listed. We're not going to talk about all the layouts in details, but we're going to talk about the important ones that are the linear layout and the relative layout. So let's change this constraint layout to linear layout as we want to discuss about linear layout. And these are the parameters of the constraint layout, so I'm going to remove that. And this line is also not required since we use linear layout now as the parent. So here, as you could see, the linear layout is created. As the name says, linear layout means that all the UI components that are used inside the linear layout will be aligned in a linear way. Let's add another text view and see. The text view that we added now is aligned next to the previous text view in a linear way, and this is aligned in a horizontal way. And if we add another text view, let's add two more text views. And if we add two more text views, all the four text views are aligned in a linear way, and this is horizontal. But if we want them to be aligned in a vertical direction, there's something called as the Android orientation, and if we change that to vertical, then the elements would be aligned vertically. Notice that the default orientation is horizontal for linear layout, but when we change it to vertical, the elements are aligned in a vertical way. Now what if we want them to be aligned in an order? We want some space between the two text views. To do that, we have something called as the weight and the weight sum. So the weight sum is allocated on the linear layout, and if we give a weight sum of 100, and if we say that Android layout weight equals 25, and if we add the layout weight to all the text views that are inside the linear layout, then that means that the 100% of the height of the linear layout will get divided into 100, and then each text view would get 25. Now if we change the value, let's say one of the text views are 50, and I'm gonna give 10, and then 30, so that the sum of the values should always equal the weight sum 100. So now if we do that, so the first text view has taken 50% of the screen, and the 10% and 10% to the next two text views, and the last one has taken 30% of the screen. So that was about linear layouts. Now let's see how to use nesting in linear layouts. I'm gonna delete 3 of the text views and just leave the one, and let's add another linear layout here. Notice that the width and the height for all the UI elements should be given, and there are only two types that we could give: wrap content and then match parent. If we give the layout width of the linear layout to be wrap content, then the width will be similar to what the width the child elements take, and if we give this as match parent, then automatically the width will be the width of the parent layout that this layout is in, and that applies for height as well. Let's say wrap content now, and now we have created another linear layout. We can move the text view from outside to inside this linear layout, and notice that nothing has changed. And if we want to add another linear layout similarly, then this is aligned vertically. This is because we have the Android orientation as vertical. Now let's give the orientation of the linear layout that we just created to be horizontal and see what happens. Let me change the orientation of this linear layout as well, and for us to be able to see more elements, we can create another text view inside the linear layouts. To do that, I'm just pasting another text view here. Now you could see the four are different. So for the first linear layout, you could see that this is a horizontal orientation. So it has two text views that are next to each other in a horizontal way. And then another linear layout is created, and then the text views are aligned horizontally. So these two linear layouts would be vertical. That is because the parent is vertical, and the component tree would give us more idea on how layouts work, and by clicking each element we could have an idea of how everything's working and aligned together. Now let's talk about relative layouts. I'm going to change the linear layout, that is the parent layout, to be relative layout, and let's delete the linear layouts that are inside. We just need a text view. I'm going to leave a text view outside and delete everything else. Now the relative layout does not have a layout weight parameter. It applies only for a linear layout, and there's no weight sum as well, and there's no orientation. So we are going to delete everything. And now if we see, there's just one text view that we have, the hello world. And if we add another text view to the relative layout, let's see what happens. Notice that the text views are not created in a linear way, because since we used relative layout and we haven't defined how this text view needs to be placed, the two text views are placed on top of each other. Relative layout means that each view is relative to the other. So we can say that this view can be below this view, or to the right of this view, or to the left of this view, or even to the top of this view. So to identify that, we need something called as the Android ID, and we can create that by saying Android ID equals @+ID / and we can give whatever ID we want. And I usually code my text views by starting as TV, and I'm going to give this 1. TV means text view, and similarly we are going to call the next text view as TV2, and we're going to say that text v2 should be below text v1, and to do that there is a parameter called as layout below, and we need to mention the ID, and the ID is TV1. So we're saying that TV2 is below TV1, and as you can see, the text v2 is below text v1. And if we want to add a space or a gap between the two text views, we could say that Android margin top equals 10 dp. So dp means dimensional pixels, and that's how spacing works, and it means that there's a space of 10 dimension pixels created above TV2, which means there's a space between TV1 and TV2. So what if we want TV2 to be in the side of TV1? And to do that, we can say Android layout to end of, and that means that TV2 is to the end of TV1. And notice that since we added a layout above, there's a space here, and we can change this to margin start, and now there's a gap between these two layouts. Now what if we want to add another text view? And to do that, we have to call this TV3, and this should be in the end of TV2. So TV3 is to the end of TV2. And similarly, if we want to create another text view, we can call this TV4, and for this we are going to say TV3. And similarly, we can create more text views we want. That's it for this tutorial. I will see you guys in the next tutorial. This is Alex Vijayaraj. Have a good one.